Today we're going to be working on another Land Rover LR3 instrument cluster, and this one the customer stated that they intermittently had issues with the whole cluster going down, and when that happened the blinkers would also stop working. Now they also mentioned that this would commonly occur if they were going over bumps, so we're going to go ahead and start by taking it apart and taking a closer look at some of those solder joints. Okay, I've removed the circuit board out of the cluster, and what we're going to focus on is this green connector right over here, more specifically the solder joints right here on the front. So we are very zoomed in with our microscope, and I want to show you the second pin on the bottom row starting from the left, because this one is the easiest one to see on camera. But as you can tell, and I'm going to try to do the best I can to show it to you, we have a little bit of a ring right here going all the way around. So that is a crack in the joints between the solder that connects to the pin and the solder that connects to the actual circuit board. As that crack gets worse, the data will stop flowing through, and of course the cluster will stop getting power or the data for the dash, for the blinkers, and so on and so forth. So this one also has a crack, but it's a little bit harder to see. It's at a different angle. Let me see if I can adjust. There's a lot of light reflection, so it's hard to tell, but there also has the beginning of a crack on it. So we'll definitely need to reflow that. So I'm trying to rotate the board so it's easier to see, but there is also a ring and actually a somewhat severe crack right here on that side, but it's hard to tell because of the reflection of the light. Okay, for this pin right over here, it looks like instead of a circular, we have more crack that just follows the actual shape of the pin. So on the side here, it looks like it is disconnecting from the joint itself. So this one is definitely another one we're going to want to touch up with the solder. Now, I don't really care if these are connects or no connects. I am just going to reflow the whole connector. So we're going to start by removing the original solder and then clean it all up, and then we're going to start with a fresh coat of leaded solder, which is allegedly less prone to cracking. Okay, I'm going to start by removing the original solder with my desolder wick. Never mind, we're gonna first have to adjust the temperature because it's way too low. All right, we'll do a little cleaning. And I do realize that I don't have 100% of the solder out of the joints, but that's okay. We just need the majority of it to be gone to make way for our new solder. And again, this is leaded solder, and I'll have a link in the video description if you're interested in purchasing this exact same solder that we're using today. And I am lingering on the joint just a couple of seconds to make sure I get good heat transfer into the pins. And another quick clean to remove some of that flux. Let's take a look at our new joints. We're going to zoom in a little bit. And the joints are going to be a little bit scratched because of my cleaning with the toothbrush. So that's what those scratches are. That's in part because the solder we use is leaded, and lead is a softer metal, so it is more prone to getting scratched. But in turn, it means it's also less prone, allegedly, to cracking, which is why we use it. And I'm seeing a little bit of flux left over on some of these joints, so we'll do a little more cleanup. But these joints look pretty clean. I don't see any problems with them. They look good. I don't think they're gonna have any issues in the future. Okay, so we finished resoldering the green connector over here. Now, if we flip the board over, there is a row of joints over here and over here, which are for the screens. Now, those, I have not seen it, but those apparently, I've been told, do tend to crack, so we are going to resolder those anyways. And then lastly is this chip. So I'm going to do these two rows off screen. We're going to focus on this chip next. So the reason I wanted to focus on this chip next is because this one also is known to have issues with the legs. So what we're going to do is, I'm going to do actually just one of the sides on screen because it is going to take a long time. The reason for is it does have that conformal coating on it. So I'm going to actually put a little bit of conformal coating remover. We're going to let that soak for about an hour or so, and then we're going to clean off the sides before we can start actually soldering. All right, this is our chip now that we have finished cleaning off the conformal coating. I ended up doing one layer of our conformal coating remover, waited about a half hour, 45 minutes, cleaned it all off, put another coat, cleaned it all off, and this is where we are right now. So I'm gonna start by actually adding some flux first. Same thing, we're gonna be using our leaded solder. And I'm just gonna be putting somewhat of a heavy coat actually. And I don't really care if I cause any bridges as of right now. There's still some conformal coating. Even though it's fairly clean, there's still some. And that's why we definitely want our fume extractor on. We're gonna clean up a little bit of that burnt flux here. And I think some of it is actually burnt conformal coating that was in between the pins that I didn't quite get fully removed. All right, this time around, we're gonna go over it again. Just gonna put a little bit less solder. And again, I don't really care if I'm creating bridges right now. I'm just gently gliding over. We're gonna add a little more flux since we've burnt off all the other flux. And we're gonna do our final pass. Another clean. Get rid of that burnt flux. So I'm going to do a quick pass with my dental tool, and I'm going to be putting physical pressure on each pin. We call it raking the pins, and what it does is ensures that every pin is physically connected to the pads. If it wasn't, the pin would then just bend, and we would visually see an indicator that the pin is not soldered right. All right, so we're going to do the other three sides off screen, and then we'll reconvene in a minute. Okay, I've now finished resoldering all four sides. I did have a little bit of an issue with this capacitor, but I resoldered it. It just got loose for a second while I was doing this last side. Now we're going to go ahead and resolder the connections over here. So again, these, and like I said, these don't actually look bad right now. I'm not seeing any cracks, but some people do say that they can develop cracked solder joints. So we're going to go ahead and preventatively resolder those. All right, and here's our joints post repair. Looks pretty good to me. Okay, we've just finished all of our soldering. So again, we resoldered these pins, this chip over here, and these pins over here. Now they were sealed with conformal coating, so we're gonna go ahead and apply our own conformal coating to seal it back up. And we're gonna be doing this outside because this does stink quite a bit. Okay, and this is our chip coated with the conformal coating. And I did get a little bit of bubbling over here. This is where some of the original conformal coating was left behind, so I think that could have something to do with it, or I just went a little too heavy on it. And we have our pins over here are also coated. Now my conformal coating is clear, so it's not that yellow dark, so it's a little harder to see, but it is there. Okay, I have put the whole instrument cluster back together. We're going to send it back to the customer. It does complete our repair. If you have any questions, let us know in the comments down below. Otherwise, leave us a like, subscribe for more content, and thank you for watching.